Hey, it's Kennedy.
And we're going to be introducing
Converting logs to exponents and back. Here's Mr. Talon.
Yeah!
Alright! Here we go. Today we're going to be talking about exponential and logarithmic forms and how they go together. As you can see up here, we've got some different colors. We've got log base b of a equals c on the left. That's the correct way to pronounce it. And on the right, we've got exponential form, which is b to the c equals a. These are used to help solve exponentials that just don't, seem to work out pretty nice. Turning them into logarithmic form, we have a lot more ability and flexibility to work these things out into something more manageable. So let's look at some problems. Right here, the first three, we're going to convert these to exponential form. We are doing this because they're already in logarithmic form. So the first one reads log base 6 of 10 equals x. A good way to remember this in Mr. Talon's class is when you have the base of the log, it turns into the base of the exponent. So this is going to become 6, okay? And then it goes to the x power equals 10. Another quick way to remember this is, like I said, base of the log becomes base of the exponent, and the 10 and the x flip sides of the equal sign. So once again, notice how the 10 was on the left, and now it's on the right, and the x was on the right, now it's on the left. All right, next one, same style, different numbers. So base of the log becomes base of the exponent. 5 to the x equals 9. There we go. One more. Same thing. Let's just go real quick. 3 to the x equals 7. If you have any questions on those, go back and watch those again. We are going to move to logarithmic form from an exponential. So these are a little bit trickier, in my opinion. I think it's harder to go backwards. Once again, we want to say the base of the exponent is going to become base of the log. This 3 is a little bit smaller here on the log, so we know it's a base. And once again, the 3 and the 27 are going to switch sides, so we're going to say log base 3 of 27 equals 3. Okay, one more to go after this next one. Log base 5 of 625 equals 4. Last one, here we go. Log base 6 of 1/6 equals -1. It doesn't matter that we have a fraction. Everything works out just the same. So, as you continue to do these, keep these tricks in mind. If you want to, real quick, we'll let Murray jump in here and tell you about her method of a simpler way to imagine these things. So, Murray, take the floor.
Okay, if you're struggling with going from exponents to logs, there's this cool little trick that I found on Pinterest. If you like it, use it. If you don't like it, I don't care. So basically what you're going to do is you're going to start on your base side. And you're going to draw straight. Oop, awkward. Where's the pen? Here we go. Now it's going to work. Alright, so you're going to start making an L. So you're going to draw straight down. So that 5 is the first thing that's going to go down here. So you got to start with the base right here. Then you draw over for the L. Next thing is 625, which is what we put right here. And if you're making like a block L kind of, you go back to the 4. The 4 is the last thing right there. And then like this, it kind of makes an L. I know it kind of looks weird. Some people are like, that's not an L.
Talon's class doesn't like it.
Talon's class apparently doesn't like it. That's fine. Whatever. Alright, next one. Say you're struggling with going wrong way from log form to exponential form. So kind of like the same thing, but instead of making an L, we're going to start with an E. So we're going to start at the 5. right here. So the 5 is, of course, where we start. Then we go to the x, so that's our exponent right here. And then you continue with the e to the 9. And oh hey, that is an e if you don't think it's an e. It's kind of a messed up e, but whatever. I hope this helps. Ask your teacher if you have any more questions. See y'all later.